Okay, so this morning we're going to be talking about types of fronts and types of pressure and the kind of weather that you can associate with them. So on this little cheat sheet that you have in front of you, it demonstrates what happens with a cold front and what happens with a warm front. Your cold front is much more dense, so it sinks. That's what this blue line is showing you. It sinks and it pushes under warm air. So the cold air is more dense, it sinks and it pushes that warm air up. And so when you have a cold front, a big air mass of cold air, it's going to bring really heavy, scary thunderstorms, a lot of precipitation. Okay? And that's what this box says. Cold air mass overtakes and pushes under a warm air mass. Okay? So cold air is bigger, so it's pushing under this warm air mass, and it brings heavy rain and violent thunderstorms. And depending on where and time of year, it'll bring a blizzard, or it'll bring, it can also be associated with tornadoes. After the storms pass, though, you'll have colder, cool weather. It might be kind of windy, but it's not going to be as stormy. So you get a little bit of calm after the storm, but you get a big temperature drop. Whereas a warm front, when a larger warm air mass meets a cold air mass, it rises above that cold air, and it kind of it overtakes it. It kind of causes the cold air to disappear, but it still brings steady precipitation. Okay, so you get slow and steady rain. Not violent thunderstorms or hail, but just, a normal summer rain. Okay, and after you get that hot, humid, gross weather. Okay, so cold front, you get heavy rains, violent thunderstorms, and a drop in temperature. And a warm front, you get steady rain and you get hot and humid weather after. So you get a temperature increase. And these are the symbols, okay? So you have a line with these half moon shapes to represent a warm front. And they're usually red. And then I like to think they look like mini suns. And then a cold front is usually blue, and you have these triangles. And to me, they always look like little icicles because it's cold. That's how I like to remember it. And on a weather map, the direction that this shape is pointing, so right here where my mouse is, you have the triangles that are pointing toward the bottom right corner. That's telling you that the front is moving that direction. And this warm front, your little circles are pointing up. It's telling you that that warm front is moving up. So you can use all of this little cheat sheet to determine what a warm front or a cold front does and what kind of weather is going to be a result. Okay, so what we're going to do here is we're going to complete this Venn diagram comparing warm fronts and cold fronts. Okay, so I'm going to make a text box for my warm front. And I'm going to add some bullets there. So what is one fact that we just learned about a warm front? That you get hot and humid weather. Now, what about a cold front? What kind of weather do you get with a cold front? Cold and dense air. Okay, so what else do we get with a warm front? What kind of rain do we get? What kind of precipitation do we get? We get steady, light rain. Whereas In a cold front, we get violent, severe thunderstorms. We get a lot of precipitation. And warm fronts are less dense. And we already mentioned that cold fronts are more dense. So I'm going to reformat this real quick so it's bigger. All right, so in our differences, we said that warm fronts are hot and humid weather. They give steady light rain and they are less dense. Whereas cold fronts have cooler temperatures, super dense air, violent severe thunderstorms. So now we need to figure out how they're similar. So what are some similarities between a warm front and a cold front? They both bring rain. The better vocabulary word for that is precipitation. So I need to make my box bigger. What else, guys? They both bring rain or precipitation, and they both result in a temperature change. Both cause a temperature change. So you get precipitation and a change in temperature with both of these fronts. Actually need to make a correction. Warm fronts, according to our notes yesterday, actually move slowly, and cold fronts move fast. So I need to flip-flop those. Okay? So again, warm fronts move slow and bring days of steady precipitation, and cold fronts bring really severe storms, but they move very quickly. I had that backwards. Another really great resource for you guys to use on your quiz is this T-chart that compares high pressure systems versus low pressure systems. Okay, so you will have your Venn diagram for warm fronts versus cold fronts, and you'll have this T-chart for high pressure versus low pressure. So high pressure is typically represented with an H. You might see it as a blue or a black H. And with high pressure systems, when you look at a weather map and you see that H, it means that the area is currently experiencing clear skies and the air is dry. And what increases toward the center means is when we look at an isobar map, like the slide below, the numbers that you connect, these rings, they are going to increase as you get toward the center. And we'll talk more about that in a second. But the weather associated with a high pressure system is going to be clear skies and dry air. And a low pressure system, which is represented with a capital L, that is usually red, it brings cloudy skies and moist air. Okay, so they're very obviously the opposite of each other. High pressure, clear, dry skies. Low pressure, cloudy skies, moist air. And high pressure systems will increase toward the center on a barometer, and low pressure systems will decrease toward the center on a barometer. Wind speed is determined by the closeness of lines. The closer the lines, the higher the wind speed. So you guys have this as a cheat sheet as well for your quiz. So this is an isobar graph, and this is what we use to read pressure systems. So here you have a map of the United States, and I've already connected the dots for you. Okay, so an isobar is this ring, and it connects equal places of air pressure. Okay, so everywhere where it says 1008, I connected those dots all the way around. So this entire circle has an air pressure of 1,008. So Montana, Oregon or Washington, I can't remember which one comes first, Nevada, California, New Mexico, Arizona, Colorado, all of these places that have 108, they all have the same air pressure. And then you go to the next ring where it says 1,012, and I just connected those dots again. All the 1,012s are connected. And so that means that entire isobar, this entire circle, they all have the same air pressure. And then the next one is 1,016, and the innermost circle is 1,020. And so what we do to determine if this is a high pressure system or a high pressure area or a low pressure area is we have to say, is it increasing? Are the numbers increasing as you go towards the middle, or are the numbers decreasing as you go towards the middle? So for this particular area of pressure, it went from 1,008 to 1,012 to 1,016 to 1,020. So pressure increased as we went toward the center of this circle. So that means that this is a high pressure system. And then that means that they have clear, dry skies in this whole area. Okay? Okay. So just a quick recap. As you move toward the center of this isobar, if the numbers are increasing toward center, that means you have a high pressure. Now on the right side of this map, I've connected all the dots, and the outermost one says 1,004, and then the next one is 1,000, and then the one after that is 996, and then we have 992. So the air pressure is changing by 4, and it's decreasing towards the center. The numbers got smaller as I went toward the middle. 1,004, 1,000, 996, 992. So our pressure is decreasing toward the center, so we have a low pressure system in this area. Okay? So that means this whole area is going to be experiencing cloudy, moist air, probably precipitation. Lastly, as you can see that I've written on here, I wrote my north, east, southwest. I wrote my compass. That's a really good test strategy. And then I have these areas circled. So on my high pressure system, the lines are much closer together than compared to my low pressure system. So the closeness of your lines determines your wind speed. So I have more wind in this high pressure area because the lines are closer together. And then if you look at the low pressure system, my lines are really far apart, which means that I have little to no wind in this area. So that's why they're circled. The closeness of your lines determines your wind speed. The closer your lines, the higher your wind speed. Lastly, now we are going to answer some questions about the isobar graph we just looked at. So isobars are the lines that connect points and places with the same air pressure reading. So number 1 says, look at the pressure area on the west side or the left side of the map and record in the table the air pressure reading represented by each isobar. Begin with the outermost isobar and move inward. The first one has been done for you. So if we go back to our map, it says the west side, west or left. So that's this high pressure map here. So it says 1,008, that was the first one. The next one is 1,012. So I'm going to go record that in my table. Okay, and then I need to record the last one, which was 1,016. So I'm going to type that into my table as well. Okay, so now you can see what each line is being read as on our isobar graph. Number 2 says, as you go toward the center, does the pressure increase or decrease? So if you look at our table, the outermost was 1,008 and the innermost was 1,020. So did it increase or did it decrease? Good, it increased. Okay, number 3 says, is this an area of high pressure or low pressure? So again, pressure increases toward the center. Then that means it is a high pressure. Okay, now we have a second table, and it says, look at the pressure area on the east side of the map and record in the table the air pressure reading represented by each isobar. 1,004, 1,000, 996, 992. Good. Okay, so for number 2, we said as you go toward the center, does the pressure increase or decrease? We said it decreased. And if you look at our table, you can see that they're getting smaller from the outermost to the innermost. And number 3 asked, is this an area of high pressure or low pressure? And to explain, we said this is an area of low pressure because the pressure levels decrease toward the center. Number 4, 5, and 6 want to know what the correct symbol for high pressure is and what the correct symbol for low pressure is. And then we're going to estimate the air pressure reading at point X. So high pressure will be a blue capital H and low pressure will be a red lowercase l. So now we need to look at our isobar graph and determine the air pressure at point X. So point X is right here where my mouse is, and it is in between the lines of 1,000 and 996. So it's in the middle and each line's increasing by 4. I'm going to say it is 998, or between 1,000 and 996. Good. And it is in our low pressure system. So what kind of weather is going to be associated with this area? And the current weather at point X, because it's in a low pressure system, they are most likely experiencing cloudy, moist skies. And that is pretty much it for isobars, pressure, and fronts. In your check for understanding, it's going to ask you about wind speeds and things of that nature. So make sure that you use these notes in this video as reference to complete that check for understanding. You have 2 really great cheat sheets right here.